All right, so I think we're ready to go here. Forgive me for repeating. I'm looking at two-dimensional motion, right? Versus instead of only one-dimensional motion. These are vectors, magnitude and direction, right? Magnitude, the amount, direction, what way it's pointed, right? But what happens if instead of doing just one motion, you do two? Instead of moving only in one dimension, what if you do two? What if Alex decides he wants to walk for a certain distance east and then turn and walk a certain distance north? Can we figure out how far he has walked without simply walking along with him? Right? What we can do with these vectors is we can actually move them. And how we move them is we call it, we're moving it tip to tail. So you can see the little arrowhead that are on the two ends, right? And so I move these two vectors so that the tip of one, this would be the horizontal one in this case, is right at the tail of the other one. Tip to tail. Does that make sense? And by doing that, what kind of an angle do I form right here? A right angle, 90 degrees, right? And so then I can say, because he's gone these two different directions, Alex has walked to some west and then some north, or sorry, this would be east and then some north, I can then make a third line to basically say this is the combination of both Alex going east and north. Does that make sense? So if I was starting here, I wouldn't have to walk all the way here and all the way there to get to him. I could just simply go straight that direction. And we would meet up in the exact same spot. And we call this the resultant. The result of the motion. Does that make sense? The resultant. Could I use math to figure out the length of that resultant? Be pretty easy, right? This is old school geometry. What formula would I use to figure that out? A squared plus b squared equals c squared. Simple Pythagorean's theorem, right? So here's my a, here's my b. I can make that, again, what we call a resultant. And I find that my resultant squared is equal to a squared plus b squared. Of course, I could also say that r is equal to the square root of a squared plus b squared. Easy, right? Old school stuff. You all have a tattoo somewhere on your body of Pythagorean theorem because it's so easy and you love it so much. Right? But what if this angle that is formed between the two is not a right angle? Like, what if it's not 90 degrees? So we can still put them together, put the two vectors tip to tail, but are you comfortable that this angle, this theta that I have here, is not a 90 degree angle? So therefore, I would have to use the law of cosines. Your textbook on page 123, they have the law of sines and the law of cosines. I have found that with this textbook, we don't really use the law of sines at all, which is just simply the ratio between them. We definitely will use the law of cosine, though. So noticing the same part, right? A squared plus b squared, but I have to add this second little piece to take care of the fact that I am no longer at a 90 degree angle, looking at the cosine of that angle there. Sir? You will want to be comfortable with that, sure. We're not going to use the law of cosine a ton, but you do. The law of sines, we will not. I will not give you that one. I don't even think there's any problems we're going to do where you have to use that one. That's simply just, if you have a ratio, that's basically what that boils down to. If you know a couple of them, you can find the other one. The law of cosines? No, sines, no. Cosines, yes, you may see a problem with that. Again, we don't use it a ton because we try to do a lot of things where we make things into right angles. We'll talk about that. But we will use it some. Does this make sense? All right, let's put it into practice. Excuse me, even though I know you all know how to do this, because this is old school stuff. This is old, easy algebra 2 that we're doing here, right? So, this time Jason's doing some walking, and he's going 15 kilometers in one direction, and then 25 kilometers in another direction. And we have two different angles we're going to calculate here. The first one is if there's a 90-degree difference between them. So let's say, again, he went east and then went north. And the second one is if it's 135 degrees between these two angles, or between these two vectors. And they want us simply to find the sum. When they say find sum, they mean find the resultant. Right? Put these two together, and let's find out how far Jason actually traveled. Okay? So, let's draw. If I'm going to put 15 on the bottom, that's going to be here, 15. And are you comfortable when I draw my vectors? They have to be proportional, right? I'm not going to actually get out a ruler to check to see did you make it exact. But are you comfortable 25 should be bigger than 15? Right? So, does that make sense? That may even be a little bit too long, but we'll stick with it. Okay, so those are my, and again we said this was a 90-degree angle that was right here. So I want to know what is my R. Can somebody tell me how I would set this up in order to actually calculate this R's number? Okay, so R equals the square root of 15 squared plus 25 squared, right? And of course, you would square the numbers first, right? Then add them, then take the square root. That's your standard order of operations, right? You do all the stuff inside first, and exponents come before multiplication and division, which comes before addition and subtraction. So what do we get? What's my R? That should be a nice funky number. It shouldn't be a nice even one. Say it one more time for me. 29.15475. Okay, we'll stop there. That's good. Okay, so where do I round this thing? Good. Now, I've got 2 here, 2 there. 135 is? Oh, sorry, 90. Good. 90 is? Only 1, unfortunately. I would never do that to you, so let's pretend that's 90.0. Did your textbook give you 90.0 or did it give it 90? Exactly. I'm looking at example problem number 1, by the way. They did say 90 on the nose. Isn't that the stupidest thing in the world? So we'll pretend it's 90.0, so we don't have to deal with only 1 significant digit. So how would I round this to 2 significant digits? Cool. I'm going to look at the 2. That's yes. Those are both significant. The 1... I ignore these guys. The 1 tells the 9 to do what? Just stay the same. So therefore this becomes 29. What are my units? Kilometers. You with me? Let's do the same thing. I think I forgot to actually clone this guy. I did. So let's clone it. And we'll erase. Okay, so this time, instead of doing 90 degrees, we're going to do 135. So, I'm going to draw my line. Again, we'll go 15 here. And then, again, approximately, this is going to be 135. Here is my R. That might be a little too big, actually, of an angle, but that's all right. There's my R. So, what formula am I going to use to solve this R now? I'm going to use that law of cosines, right? And I can't use Pythagoreans. Why? It's not a right angle. It's got to be 90 degrees if I'm going to use Pythagoreans. So therefore, R is equal to the square root of a squared plus b squared plus what? Oh, not plus, it's minus. Minus what? 2ab cosine of theta. By the way, make sure your calculator is set on degrees to do these. We don't do much with radians here in this class. So do make sure when you're using your cosine, it is in degrees, not in radians. It'll give you a different answer. So I plug in 15 for A, 25 for B. Oh, pause for a second. Does it matter if 15 is A or if 15 is B? It doesn't. Either way is fine, whichever way you choose. If Kirsten really wants 15 to be B, cool, it's fine with me. Not going to hurt my feelings. I plug them in, and what do I get? Somebody give me a number. Okay, 10.15 and change.
But I did on my phone, so I don't know.
Yeah, that's not what your textbook has. Pop them in, please. Because this is where I want to make sure you know how to do this. If you're using the Apple phones, you'll have to do the cosine first. Cosine of theta, then multiply by B, multiply by A, multiply by 2. Write that number down. The phones are a pain for these kind of things. Then you got to square A, and then you got to square B, and then add and subtract the pieces. And then take the square root. So what do we get? Anybody? What'd you get? It's close. 37 point what? 0.15? There's a bigger number than that, right? 37 point. Give me the rest. Okay, cool. How many significant digits are we going to round this thing to? To 2. Because 15 is 2, 25 is 2. Even though 135 is 3, we're only going to round to our least number, that's 2. So therefore, 3, 7, the 1 tells the 7 to stay the same. I ignore the rest of those. So therefore, R equals 37 kilometers. So are you comfortable that if we need to go find Jason when he's walking at that 135-degree angle, we have to go further than if he's walking at that 90-degree angle? That makes sense, doesn't it? Because this is much shorter. That R here with a 90 degree is much shorter than the R at the 135 degree. So that just, like common sense wise, yeah, okay, I did that correctly. Does this make sense, my friends? Our point is simply I had two vectors, right, that I moved and made them tip the tail. And based upon the angle between those vectors, I either use Pythagoreans or I use the law of cosines to find my answers. Any questions there? Pretty straightforward, I hope, right? So, we are going to do, please, this is 5, right? Chapter 5? Yeah. 5.1. It is on the page that has the number 124. And you are going to do numbers, please, 1 through 4. And you've got a solid 15 minutes. No, sorry, 20 minutes that you can work right now. So go for it.